So this one looks pretty complicated, but actually it is simpler than you think. So I would say that this is a geometry question on splitting and regrouping. And regroup. All right. So, how do we do this question? Essentially, there are two ways we can do it. The first way is that we can just cut it up layer by layer to imagine that apart from the gray parts that we are seeing, how many more of them can be white, right? So that's for the top layer. For example, that is a 3 by 3 grid. So you can see that these 5 are going to be shaded. So 4 are blank. And then for the second layer, we can see that only the 2 on the corners are shaded, which means that 7 are blank. And for the bottom box, we can see that only the part we are seeing, which is the outer layer, is shaded, which means that 4 are blank. So if you add those up, you're going to get 15. And also a simpler way to do it, so this is like splitting and regrouping, but then actually there is a simpler way. The simpler way is that you just need to count the number of boxes which you can see to be gray. 8, 9, 10, 11, 12. So there are 12 cubes that are painted gray. What about the others? We don't have any information about them, right? Apart from these ones. So the others can all be white. Of course they can, because I can't say that they are not white, right? From what we are seeing. All we can see is that 12 of them are painted gray. So the maximum possible number of white cubes that are not painted gray is just going to be 27 take away 12, which is 15. Okay, so that's how we can solve this question. Not too hard, not too hard. But then this question is definitely pretty daunting if you're just looking at it. Okay, so we are at question 22 now. So this one is again a kind of like a gift, but then I am a little bit surprised that not all of you are doing this right. So essentially, you just need to know how division works. Basically, the division is just the dividend divided by the divisor, and it gives you the quotient, right? Which means that the dividend is equal to the quotient multiplying the divisor, of course. For example, 6 divided by 2 is 3, so 6 is 2 times 3, right? So, how can we make use of this to solve this question? First of all, this is definitely a numbers and operations question. And it has got to do with division, or the property of division, all right? So it belongs to the 4 basic operations. So when the result or the quotient is adding 100, it is going up by 100, it means that the dividend is going up by 100 times the divisor, 18, which is 1,800. So what is the dividend in this question? 952473. If you add 1,800 to it, you're going to get 954273. So which are the digits that are swapped? It's pretty clear. 2 and 4, right? So 2 and 4 are swapped. That's how we can solve this question, because like this, 954273 is going to be the new dividend for the quotient to be going up by 100. Okay? So that's how we can do it. That's how we can figure out this question. And for question 23, I might need to hide my head again. So this is a miscellany question on the number arrays. Okay, so how does this work? Essentially, we need to know that first of all, we are counting 3 sums of the 3 lines, right? In this question. And definitely, if I'm counting the 3 sums, there will be 3 numbers that are counted twice, which are 5, whatever this is, let's call it question mark, and 2. These 3 numbers would be counted twice. So we can think about it as an inclusion and exclusion scenario, such that the combined sum is going to be equal to the separate sum, take away the overlap. So what is the combined sum? If you just combine the 3 sums together, you can see that it consists of all the digits from 1 to 9. So the combined sum is 1 adding 2 adding 3 all the way adding up to 9. And what about the separate sum? It means that we are separating the 3 sums we are trying to look for, right? So let's say that's going to be 3 times the total. So let's say this is 3t, all right? Let's say this total is t. And then what about the overlap? The overlap is going to be the question mark, the 5, and the 2. So it's 2 adding 5 adding question mark. In brackets, of course, because we need to take away the whole lump sum. So now you can see that 1 adding all the way to 9 is 45, and that is equal to 3 times the total, take away 7 adding question mark. Which if you reallocate the terms, you can see that 3 times the total will be 52, which is 45 adding 7, adding question mark. Now, that's the most important step in this question. We know that the total has to be an integer, right? So it means that 3 times the total has to be an integer multiplied by 3. Which means that it is a multiple of 3. Which means 52 adding question mark is also a multiple of 3. Okay? So what is the next multiple of 3 after 52? It should be 54, right? 52 adding 2 is 54. And the next one, 52 adding 5 is 57. And the next one, 52 adding 8 is 60. So these are the 3 possibilities we have. But then we can see that 2 and 5 are already used in this question. We are using 1 of the digits from 1 to 9 each, right? Once each. So, if 2 and 5 are already used, it means that the only possibility is the question mark equals to 8. All right, so that is 8. Now we can see that 3t is going to be equal to 52 adding 8, and that's 60. If 3t is 60, then t is going to be 60 divided by 3, that is 20. So the answer is D, that is 20. Okay? So that's how we can solve number array problems. The next time you see these kinds of problems, you can use a very similar method. Try to use a similar method to tackle it, all right? And most of the time, it is going to work. As for question 24, it's going to be about cutting up regular polygons. So it will be a geometry question on cutting up regular polygons. So how do we cut up an octagon? Basically, first of all, we can see that this shape has got a square, 4 rectangles, and 3 triangles in it, right? And how we can cut the polygon up is actually by drawing a cross inside the square. All right? So after doing that, I get 4 triangles, and let's say each of them has an area of A. These 4 triangles will be the same as these 3 triangles. Each of them will be the same as these 3 triangles because they all have the same base, which is the side length of this regular octagon, that is 1. And all of them are right-angled isosceles triangles, which means that they are actually just going to be identical triangles or congruent triangles, if you heard of this term before. But if you haven't, don't worry. This is just something that you can remember. Whenever you're cutting the octagon up, first of all, you can just do something like what the question was doing and then draw a cross in the square in the center. Okay? And of course, because it is a regular octagon, these 4 rectangles, they has to be having the same area as well. So now we can see that the difference between the area of the hatched region and the shaded region is going to be, well, for the hashed region, it is 4A adding 2B, right? So 4A adding 2B, take away what is the area of the shaded region? 3A adding 2B. So the difference in area is going to be A, which is the area of one small triangle. And what is the area of one small triangle? Well, we can make use of the square in the center. We know that this square in the center is cut into 4 sections. Each has an area of A, right? And the square in the center, of course, it has the same side lengths as the regular octagon, because you can see that the opposite sides of the rectangles has to be the same length, right? So the dimensions for the square is going to be having a side length of 1, which means that A is going to be a quarter the area of the square, which the area of the square is 1 times 1, that is 1. So it's going to be a quarter of 1 times 1, which is a quarter. So C is going to be the answer to this question, all right? The area is going to be a quarter, like the difference in area is going to be a quarter. All right, so that's question 24. And finally, this question 25. So I'm hiding my head again. And this one is actually like the hardest question in this paper if you are not understanding what it wants you to do. All right. So basically, it will be about geometry. And first of all, it will be about spatial imagination or recognition, spatial imagination and recognition. Let's say spatial recognition. And it's also about nets. And I'll tell you why later, okay? So it says that a die has the shape of a regular tetrahedron. So how does a tetrahedron look like? It basically looks like that. It means that it has got 4 faces and each face is a regular, like equilateral triangle. So if you want to find the net of that, it is either gonna look like this, which if you consider the center box as the base, then these 3 sides are gonna fold up into the base, right? So this is how the net's looking like. Or, of course, you can also try to unwrap it in the same direction, which is going to give you something like this. Okay? And of course, in each of these nets, there will be all 4 of the number of pips on it, because like it's going to be wrapping up into a tetrahedron, right? So from what we see here, we know that this is 4, 1, 2. So the remaining one on the top is 3. And for example, we can also find this part as 4, 1, 2. Like there's a trapezium shape as 4, 1, 2. So it means that this one on the right is going to be 3. And actually in this diagram, for whichever 4 equilateral triangles you take, it's going to be a net. Because definitely it's going to be following how the die is looking like, right? So it means that every 4 units looking like this is going to consist of all 4 numbers. So now you can imagine what we want is the corner grid, right? What we want is the number of pips facing down for the corner grid. So we can just imagine rolling it along the edge until we get to the corner, like the corner box of this grid. So this is 4, 1, 2, 3, right? So what do you reckon is going to be the number in the next box? As I said, every 4 in a row is a net of this die, which means that if I have 1, 2, 3 in a row, the remaining one must be the missing number 4. And if I have 2, 3, 4 in a row, the missing one must be the remaining one must be the missing number 1. So following that logic, we have 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. But then I'm stuck right there. How do I know which is the next number that goes into that blank? Don't worry, it's pretty easy. Because we can see that if 4 is on the left and 1 is just right to it, 3 should be on the top, because the next one is going to be 2 right there. Yeah? So it means that 3 is going to be on the top. 3 is going to be on the top. Imagining that if you go ahead, it's going to be 2 instead of 3. So 3 is going to be on the top. Now, I just need to go up to this box. So if I have 4, 1, and 3 in these 3 boxes, this last one must be a 2, right? So this is a 2 right there, and 4, 1, 3, 2. So if I have 1, 3, 2 in the first 3 boxes, the remaining one is going to be 4. And then, what about the next one? 3, 2, 4 in the first 3 boxes, the remaining must be a 1. So the answer is 1. All right. So you can see that it's a little bit like spotting the pattern, because if you roll a die, if you roll a tetrahedral dice along the bottom, it's going to be, well, unfolding itself completely, like, and continuously. So it's going to always be like each 4 of them is always going to be folded up into the net of of the dice. So that's how it works. That's how it works. All right. Of course, there can be different ways that you can do it. For example, like the solution in the, like the official solutions that the UKMT is providing. But I personally believe that this is a better way to understand this question, or an easier way to do this question, okay? So yeah, that's everything for the second half of the paper. I hope you did understand that. I hope you did. And I will see you next time, okay? See you next time. Bye bye.